Okay, in this video I'm going to show you how to run a field line trace inside of a tokamak using Heat, the Heat Flux Engineering Analysis Toolkit. I'm assuming you already have the Heat app image installed on your Linux machine, and you need a G file as well. For today I'm just going to be using this G file, which came from the tarball for the test run, which is available on the GitHub page. And there's a whole video about how to download the app image and download the test run case. So if you haven't seen those videos and you haven't downloaded them, go watch those before you do this video. But basically, I need an EFIT and I need a point that I want to launch from. So I got the EFIT. This is the GEQ disk, which is a magnetic equilibrium reconstruction in EFIT. And then the Paraview window that I have open here has a PFC in it. Let's change it. It's very bright. Okay. So basically what I'm going to do here, let's turn that off. I got this PFC, which is from the lower diverter of an STXU, and this is what comes in the test case. This is an STL. So here I'm showing solid 844 _3mm.stl. So this is an STL file. Any STL file can be loaded into Paraview, and you can do this. You can launch field line traces in Heat from anywhere. It's arbitrary. You just put in the XYZ coordinates. But I'm going to show you using this STL in Paraview because it's sort of useful. So I'm going to come over here to the interactive select cells on, and I'm going to zoom in. Let's turn this to be surface to surface with edges. So this shows us all of the triangles that make up this STL mesh. So we're just going to launch a field line from any one of these. It doesn't matter. It's arbitrary. So here is the triangle I've selected. You can see it in pink there. I'm gonna turn off the select cells. I'm gonna come over to this split horizontal button, and then I'm gonna enter spreadsheet view. Once I'm in the spreadsheet and I have solid 844 showing, I'm going to click on this little dotted green box, show only selected elements, and that will show you these three vertices of this pink triangle. So I'm going to arbitrarily choose this top one, and that's where we're going to launch field lines from. So this is points, this is X, Y, Z. So the next thing I need to do is, so keep that in mind, and the next thing that we're going to do is we're going to launch the Heat user interface. So I'm not going to go into this very deep because it's covered in other videos, so I'm just going to go to the directory where my Heat app image is. We can see here it is. It's this Heat app image in green. It's an executable file. I'm going to run it. It's going to launch a Heat server. It's going to, under the hood, launch a Flask server that'll take a couple seconds to start up. So there it is, 127001, port 8050. So we're going to come over to Google Chrome. We're going to launch that, and then we're going to browse to that port. Not to 127 hours, but to Heat. And so here we're going to do a couple things in the user interface. This is very easy compared to running a full-blown heat flux or temperature run. Field line traces are the easiest thing you can do in Heat. So I'm going to select a tokamak. This tokamak, like I said, is an STX. I don't even need to load an input file for this. All I need to do is look at my G file and see, okay, I was shot 204.118 at 4 milliseconds. So I'm going to come over here and just type in 204.118. I'm going to say just bound the 4 milliseconds however I want. So I'm going to go 0 to 10. This doesn't matter, so I'm just going to put in 0 for the number of trace steps for this. And then I'm going to just take my G file and drag and drop it into the Dropbox. It says it loaded it, and then I'm going to make sure 2D plasmas is selected, and I'm going to load the MHD. This will take a second, and it'll load up this file. So this is the magnetic equilibrium that was in that G file, that EFIT, that GEQ disk. So that's it. All I got to do now is come over to the, so I don't have to fill in any of these other boxes. For field line traces, it's just the MHD settings box. So I come over to Run Heat. I'm going to turn off this Heat Flux point cloud. That's the default in Heat, but we don't want that in this case. We want a B field trace. So I'm going to walk you through what these boxes mean. So X, Y, and Z are the points that we're going to initiate our trace from. So I'm going to come back over here. I'm going to have to jump back and forth for a second because I don't have two screens on this screencast. So 564.99, that's the x coordinate. 564.99, these are all in millimeters. And they should be in the STL too. 150.884, it's the y coordinate, 150.884. Negative 1603.32 is the z coordinate. Negative 1603 point, look, I've already done this one. So now I have the points I want to launch from. I need to choose an ion direction. I think in a future version this will actually be called power direction or something, or trace direction, because technically the electrons flow along this line too. But we're going to just choose -1, and that's going to correspond to the negative toroidal direction. And then I'm going to put in degrees 360. So what this means is I'm launching from this XYZ coordinate a field line trace in the negative toroidal direction that goes for 360 degrees, or one full toroidal turn. If I put in a 0, it's going to go 360 degrees in the negative toroidal direction and positive toroidal direction. And if I put a 1, it's just going to go in the forward toroidal direction. So this can be -1, 0, 1. And I'll show you, we'll do 2 of them. So here, we'll just run this 1. We're going to run it. It'll take a second. If we look at the terminal, it's already done calculating the field lines, and it's just writing the process. And so it doesn't say anything mind-boggling in here. It just says nothing in run list can be run. And so that's when we know that the field line trace is done. So, and it also says it down here, heat run complete in yellow. So let's go back to Paraview. Actually, before we do that, just make a note of where your data is being saved. So this is on the Inputs tab. The first thing is, where is your data being saved? It's usually your home directory on Linux /heat/data. And then because we're NSTXU, this is going to be a folder called NSTXU, and then it was shot 204.118. So let's go back to the run page. And okay. So I'm going to close this spreadsheet view. I'm going to make sure I'm not still in select a point mode. I'm going to turn off the surface with edges. We see our point there in pink. So I'm going to go browse to that directory. So here's home Tom heat data. And then, like I said, the shot is NSTX _204.118. 204.118 is the shot we just ran that we typed into the MHD box. And then 4 milliseconds is this G file. And so we're going to go to Paraview, and we're going to open this field trace.vtk. And I'm going to hit apply. And voila, that's 360 degrees, and this one was the positive toroidal direction. We can edit this. Let's make it a different color. Let's make this one, I don't know, pink, and then make it larger. So make it 3, the width. And so yeah, there it is. So something that we can see here is if we look at this PFC from the side, it's going around the machine toroidally, but along the flux surface is sort of going up pretty much vertically in the Z direction. See, there's the Z direction. It's going a little bit in R, but it's also going up in Z. If we go back to our magnetic equilibrium, if we were launching from this point, which is where that tile is, we're basically going up, but a little bit in the R direction. So that makes sense. So let's switch it to -1. And just run the same thing. And this, after you've done it once, it'll take a minute because it gives you a chance to not overwrite the file. So we'll just let it think on it for a second, and then it's going to clobber the file that we had already saved. So in Paraview, that field line trace file will be overwritten. So there it did. It just overwrote it. So if you wanted to keep that file, you'd need to rename it. And then we open. It's already in that directory again. We're just going to open the other side. So this one is -1. Let's make it a different color. Let's make it yellow. And then let's make it a little larger. And so what we see is they connect right at the point, and one goes in the positive toroidal direction, one goes in the negative toroidal direction. And so we have 2 field line traces. And so then if you ran the ion direction as 0, it would just create both of these at the same time. So yeah, so that is how you do a field line trace in heat. It's pretty easy. I hope it was useful. When you get the hang of it, you can do this in 30 seconds or so. But yeah, if there's any other features or use cases you would like to see a video on, just send me an email. My email's on the GitHub page.